Bismillahirrahmanirrahim. Conservative field, conservative vector fields. So in this video we are going to discuss the conservative field. A field is conservative if this definition satisfied. This one, if it's conservative field if we can put it in the grade of phi, where phi is a scalar potential. So this is the condition for a conservative field. If we can find a scalar potential whose grade is f, then f is conservative. A vector field f is conservative if we can put it in this way, where phi is a scalar potential. So gradient mean this, that is gradient of phi, where phi is a function of x, y and z, is a scalar function. Okay, so if we have a conservative field, then this will happen, path independent work. So in a conservative field, moving from one point to another is independent of the path. Moving that way, we have 2 points A and B, or this way or that way, same work is done. So the work done between A and B is independent of the path followed. Closed integral is 0. That is work done in a closed closed path is 0. So you see both of these paths have the same work done. So moving on this on that side this way and the other that way, that is a closed path, but both are equal, so they will cancel each other. So the work done in a closed loop in conservative field is 0. Curl of the conservative field is 0. So this is another definition of a conservative field. If we find that the curl of f is 0 vector, then f is conservative field. Okay, so here is a simple proof for it. F is conservative, that we can put it in the grade of phi, and taking the curl of this on both sides, you see curl of grade phi, but this should be 0 because grade, this nebula and nebula phi are in the same direction, so curl is 0. This is one direct proof in one direction, and we will do it in the opposite direction as well. For a conservative field, curl is 0. That is the curl condition for the conservative field. So we have two definitions for a conservative field. If curl of f is 0, then f is conservative, and if we put f is grade of phi, where this is a scalar potential, then f is conservative. So this is the definition of conservative field. This is also the definition of conservative field. So we have quick example. If phi is this, then f should be this one, because f is grade of phi. So grade of phi, differentiating this with respect to x, I, then y in j direction, and then z in k direction. So this is grade of phi. So this should be a conservative field. this should be a conservative field. Why? Because we can find a phi for it whose gradient is this f. So this f is conservative, and you can prove that the curl of f in this case is 0. Second example, if we have this type of phi, then the field is this. This is again simple case. F is grad of phi. So grad of phi, differentiate this function with respect to x, that is y plus z direction I. Then with respect to y, so that is x plus z in j, and differentiating with respect to z, that is x plus y in k. So this field should be conservative because we can find phi which is equal to this one, whose grade is this f. So this is a conservative field. This is another example of the conservative field. Work done is independent of the path. So let's do it. If we have a field, then work done by that field f is this. From point 1 to point 2. This is the work done. Okay, but we see that f is conservative, so we can put that we can find a phi whose grade is f. Is conservative, so f should be put in the form of grade phi. So I put the value because f is conservative. Now we see that this is totally equal to, you have to work on it. I am writing it directly, or ask if you not find it. This dot product is totally d phi. So d phi, that is the work done. D phi mean the integral and differential cancel. We get phi from P1 to P2. So and that give me phi at P2 minus phi at P1. So the initial and final points are necessary only. The initial and final point are necessary. Phi at the final position and phi at the initial position, the difference will give me work done, not the path. You can follow any path because the path not matter. We can find the work only knowing the point A, point 1 and point 2. So that is work done. Work depends only on the initial and final points. So work is independent of the path if we are in conservative field. So it becomes easier for us to find works in conservative field because we need only 2 points in which the body is displaced. Applications of the conservative field is there are Numeral application in mechanics, gravitation, electrostatics, and fluid dynamics for the conservative field. Every gradient field is conservative and possesses scalar potential. So if you have a scalar potential whose gradient is it give me the field, then that is gradient field, and it has a scalar potential phi. Mean this mathematical equation is explained in this assertions. Okay, conservative field can be put in a grade phi, where phi is a scalar field. Okay, if you find this video helpful, like, comments, and subscribe. Okay, thank you.